This lesson is really just going to show you a few things that you'll see at different points when you're looking at scatter plots. One of the big things is there are different types of patterns that can show up. So let's go through and take a look at a few different ones. Here we see the scatter plot, and we don't know what the x value represents or the y value, and that's how we're going to keep it for all the examples. But basically, you could see that this is a positive relationship. Well, that is a pattern that you would see. If we did away with it and started looking at other patterns, we already are aware of the basic negative relationship, and that's fine. We're also aware of the no relationship, where it's just scattered throughout, and there's no positive or negative pattern that's there, because quite frankly it's just set up to kind of balance out, and there's no direct relationship, as you can see right there. But there's also other patterns that you would see, and it would be proportional, starting from the origin and going in a straight line. Now, even though we're not using a line, you can see all these dots would be on a straight line. So that would be proportional. If it's not coming through the origin and it's not a straight line, it is a straight line, but it's not coming through the origin, we can't use the word proportional, but we could use the word linear. Well, this data has a linear approach, and it doesn't matter whether it would have a positive or negative slope. That would just be another term that you could throw in there describing the patterns. But all that we're trying to do is describe the scatter plots that we're seeing with words. And so we would say, well, this is linear, and we would also say it's got a positive slope to it, or it's a positive linear scatter plot relationship. So that's what we're talking about when we look at patterns. But there are some special situations that you see, and usually it's called clustering. And for instance, let's just draw a positive relationship that's going up, and I'm not going to have it be linear. I'm going to have it kind of widened here on both sides. But then if I saw at some point on the graph where there are a bunch of extra dots, like more than any other spot, and you can see here there's just a ton of dots right here, you would say this area right here would be clustering. That occurs when all the data is grouped in a certain area, or at least part of the data there. Another example that I've seen before is that it's almost like a linear line, but then there's a lot more at some point, and there's the clustering effect right there. And the other thing that we need to discuss, and I mean, it's, you don't try to make it harder than what it is. If you can see the pattern, whether it be negative or positive, even if I put one right here that kind of fits, it's right in through there. Okay, it's a little bit different, a little bit lower. But if I was to put one, and I'm even going to change the color right here, this does not fit with the rest of these pink dots. This dot right here would be considered the outlier. It's the weird anomaly. It's something that doesn't really fit in the relationship. There could be something strange, if we were considering the whole relationship. A lot of times in statistical analysis, we just ignore the outlier. But the outlier is usually something that's a long ways away from the rest of the relationship that just does not fit in. And the question that I normally get is, well, how close does it need to be part of the group, and how far away does it need to be an outlier? Well, if we said this part right here, I don't know if I would really consider that an outlier. It doesn't seem extreme. But someone else, they might say, oh no, that's really bugging me that it's so far away. It's a little bit further than this one. But to me, I don't know if I would consider that an outlier. Maybe once we got up to about here or so, that would be an outlier, but I would feel even more comfortable if it was further away. usually the examples, if they're ever going to ask you if it's an outlier, will be so um, obvious that you'll have no problem identifying an outlier.